So this one is one of the first types of applications I remember even learning when I first got into reverse engineering. Now I've worked here for 16 years now, so it was before that because I was a customer, and when I first got into this, but impellers were one of the original case applications for 3D scanning, because as you can see, looking at the surface geometry here, it's very complicated and very difficult to model and recreate this without this type of technology. So the turbine impellers, and again, these are used within turbos, within power gen, within pumps, all kinds of different examples of these types of blade applications everywhere. And there are just billions and billions of parts and designs out there. And a lot of these have legacy designs where they need to remanufacture that same exact one from 50 years ago, right? So this is a legacy type application that we've done for a long time, and it is just a really cool application. So let me go ahead and switch over to Design X, and I will show you that one here. So we'll just toggle over. And we'll just see, does it, okay, it does that again. So there we go. All right, so as you can see, I have the 3D scan of the impeller. And we just will roll back in the history tree. And we'll step forward. So the first stage here is extracting the revolve. Now the order of operations can be slightly different depending on the person modeling here. So in this instance, we went ahead and modeled the center revolution. And while that is the most simplistic portion of this, there's a really neat tool in Design X that helps you do this very fast. And it's actually the mesh sketch setup. So let me just edit the mesh sketch real quick and turn off the mesh itself and go normal 2. So you see, this is the profile that we drew. Very simple to draw that profile, right? But what I think is really neat about Design X is this ability to edit the mesh sketch setup. If I come in there, you'll notice right away that what we were able to do here is take that scan and use a center line, this rotational axis, vector 1, and silhouette the entire part to create that profile. So what's really nice about this is if I were to reverse engineer this with other platforms, you see you want that center line here. And it is possible to get that profile of this revolution other ways, but what we're able to do is silhouette the entire thing. So it's like unrolling it about that axis, and then you can see that I have this profile and it's averaged about the whole shape. So if I were to slice through one section and it was a bad section and I used that to reverse engineer, then I created a model from a bad cross section. What this allows you to do is to consider the entire revolution and reverse engineer that. So the silhouette feature is really clutch for reverse engineering these rotational shapes like this. It also works in 2D. We have a planar silhouette as well, but this example is using the rotational silhouette. So that's how we were able to draw that sketch and then revolve it so quickly. Now the next step is to go ahead and fit the surface of one of the blades. So this is clearly a patterned piece, right? So I know that there are a certain amount, I think there are 10 of this blade here, and what I need to do is just model one of them and pattern it. So what we used is what we call mesh fit. And the mesh fit tool will allow you to select scan data and fit stuff automatically to it. So if I come over to polygons here and just, I'm not gonna spend a lot of time here, but I can quickly select that top surface. And then you see that we have a lot of different methods and wizards available. And one of these is called mesh fit. You can fit this as a loft or just a fit like we're doing here. Mesh fit is basically just going to drape that surface over the part, and you can adjust, again, the smoothness, the allowable deviation, or the resolution. And if I just hit next, you'll see here that it wraps the surface around, and there's a ton of settings in there. You see that we fit that on there. So it's really quickly able to do that. Now, we can use that other method that we used from part number 1 where you can draw. There are some customers that I have where they prefer to remodel these, and you could draw the shape and do a boundary fit surface as well. This is just the method that this person chose to use here. So I will go ahead and delete that, and we'll continue on here. So after they created those 2 mesh fits, they went ahead, we just roll forward, and created a surface and a trim. So, well, they created a sketch and a trim, and trimmed the top of that surface using that sketch there. And if we just roll forward again, they drew another 3D sketch along the top of that surface and did a trim too. So just in case anyone doesn't know, I'll just take a second to show this. But you can do 3D sketch. So if I come over and do a 3D sketch and draw just right on this surface, I can use that for trimming. So that's what they did here. And if I just exit this, I can say I want to do a surface trim. The tool entity is going to be this sketch, and the target is going to be this surface. And if I hit next, I can say which side I want to keep. So you don't have to use other surfaces to trim. I think some people will do that, and it's just fine to do that. It works just fine as well. This can actually save steps, especially when you have a mesh in the background that you can just visually see and trace a shape and use that for trimming. So that's what they used here to trim these surfaces. Is on one of them they did a 2D sketch, and on another one they did a 3D sketch to trim those. So long explanation there, but it is nice to show some of these tips and tricks along the way so you understand how the person accomplished the tasks here. So there are probably, like, I've seen people model these blades probably 5+ different ways, and this is kind of the surface trim them together method. You could revolve a solid and then use these to trim both sides of the solid as well. But in this instance, what they did is they created another mesh sketch silhouette, and this time they drew the outside of the blade and then went ahead and trim those together. Then they created a surface loft along the top, extended it, and trimmed the top together. And again, there's a whole host of ways of doing that, but that's the method that they used for this one. Now, another really creative way of doing the inside. So instead of, what you need to do now to make this a bounded solid is draw the profile for the inside, what we already drew for this, right, for the center rotation. So we've often used this as a shortcut here, is take this and do a surface offset inward. So if I hide the solid, we just selected those surfaces and did a very small offset inside the part, and then use that to now trim with the other piece. And once you trim that, this becomes a solid. And because we did it offset in, you're guaranteed that it intersects the main body. So we offset it down here. And then once we did that, they did a full face fillet on the top to make it round there. And then your good old circular pattern to create the others. And then they went ahead and merged it in. And then because this one has multiple blades to it, we'll do the same process here again. So I'll just step forward a few steps here. So we're trimming these together. Same exact steps, offset inward, circular pattern, Boolean merge, and we're almost to the end here. And then here, they went ahead and modeled the balancing. So those scallops there, so after they create this, they will balance it to make sure that it is, and that's what these scallops typically are when I see them, is they remove material so it's not vibrating. And then we went ahead and did another sketch on the top and cut those away, added some fillets and extrudes. The fillets are for, it's taken a second because it was filleting the entire part there. And there we've created our impeller blade design.